Hello everyone, welcome back to my YouTube channel. Today we are going to see class 8 science chapter number 4 current, electricity and magnetism. As we all aware of that current electricity is now the very important part of our life because number of appliances which we are using is working on current electricity, and without that our day will not be complete. Another part or the another concept which we are going to learn in this particular topic is nothing but the magnetism. So today we are just going to discuss about the current electricity and the various terms associated with it. Magnetism in a later part we will discuss. So when we talk about the current electricity, that if we will see this particular term, current electricity, it's a combination of two words, current and electricity. In a general English, when we talk about the word current, it means flow of something. Even in a general English, we are using the word current for the water also, current of water. Even for the breeze also, we are using the current of breeze. So this word current means only a flow of something. When it's combined with the electricity, then it brings the concept of a flow of electrical charges. Because electricity is nothing but what the energy is stored on the electrical charges. It may be a negative charge electrons or the positive charge protons. When we talk about current electricity, we are using it in an electrical or we are transmitting it from one place to the another place with the help of electrical wires, or we are consuming in electrical bulbs or various electrical equipments like a washing machine, refrigerator, air conditioners, electric iron. So many examples we have of electrical appliances where we are using the electricity. And even the portable source of energy like batteries, car batteries, scooter batteries, bike batteries, trucks battery, or the battery in our wristwatch or the wall clock or the toys. These batteries are nothing but the source of energy. And the common thing in all this is there is a flow of charged particles. You can see they have mentioned also the flow of both negatively and positively charged particles. The charged particles present in this sources of energy or the materials through which the electricity is flowing is all having is the charged particle. Now the next term what we have to discuss is electrostatic potential. When we talk about this electrostatic potential, before that, we should recall some of the things in our vicinity or in our surrounding. Like if we have a rubber ball in a hand and we are throwing it upward, then it shows or it shows the certain height or it goes up to a certain height, and then from there it returns back. Because every object is existing on the earth's surface is always trying to settle at a lower energy level. Even when we talk about the water kept in a bucket or in a glass, if we start to pour a water out of it, then it always comes downward. Because if we are holding in a hand, then the energy level is a much higher, and as soon as we are pouring from it, it settles down on the floor with a lower energy level. Same way, when we talk about the electrostatic potential, charges are always moving from higher energy level to the lower energy level. And this electric level decides the direction of a flow of electric charges, and this is called as electrostatic potential. You can see here they have given tendency of a positive charge to flow from point of high electric level to a point of lower electric level, and this level decides the direction of a flow of electrical charge, and that is called as the electrostatic potential. Now the next part what we have to discuss, or the next term what we have to discuss, is the potential difference. Now this two different levels, the higher energy level and the lower energy level, difference between their levels is nothing but the potential difference. In electricity part we are discussing height of a waterfall, the temperature of a difference of a hot and a cold body is the difference between the potential of a 2 points, that is potential difference, is interesting to us. This they have given in this particular sentence. After this, they have discussed about the electrical circuit, a general electrical circuit. They have shown electric bulb and the wire is used to it. In this, you can see it's a complete one cycle. Whenever we are talking about the electrical circuit, the most important part of any electrical circuit is that will be a closed circuit or the closed loop. If you are starting from any one point in the electrical circuit and you are passing through all the conducting wires and the equipments, you can make a one complete cycle. If it is not completing or it's not returning to the same point from where we started, then that will be called as a incomplete circuit or the open circuit. Electrical circuit should be always a closed circuit. Now here in the next figure, they have given about the proper electrical circuit. You can see here this is a source of energy, that is a battery we are using. This positive and negative sign what they have shown, that is for the battery. The battery is having positive and negative sign. Then the electrical wire is used and it's passing through the electrical bulb and then it's coming back to the battery. You can see we started from the battery and we ended again back to the battery. It means it is a closed circuit, so it is going to work. Next part, they have given about the electrical cell. Before that, they have given about the units. Electrical charge flowing through a wire in 1 second can be called unit current. The SI unit of electric current is coulomb per second or ampere, which also we are writing with the letter A. A stands for ampere. Whenever we are talking about the flow of electrical charges, then if in a particular conductor or the wire, in a 1 second, if a unit current is passing, then it's called as the electric current, and the SI unit for this will be a coulomb per second or ampere. And when we talk about the ampere, the 1 ampere is equal to 1 coulomb per second, or 1 C upon S. Electrical current is a scalar quantity. It don't require any direction. It's just having a magnitude. The next part they have given over here is the electric cell. Electric cells is a source required to produce a uniform flow of charges in circuit. Such general device is an electric cell. We are using a different kind of a cell, but the most important part is about all the different kind of a cell is nothing but there will be a two terminal, one is a positive and one will be a negative. Example we are going to take over here, the first example they have taken is of a dry cell. Dry cell we had already seen something like this, a dry cell, and is having a terminal over here. So this marked as a positive and this marked as a negative. If you had seen a dry cell or the pencil cell which we are using for the wall clock especially, and for the toys also we are using, so it's all are having a positive and negative terminal. The positive terminal is like this and the negative terminal is a flat. So this positive and negative terminals what we have, what exactly they are, that they have in the next picture they have shown what exactly we have inside the dry cell. You can see this positive terminal. This is the center one is a positive terminal. The carbon rod they are using in it carbon electrode, the name given to it as a carbon electrode or the carbon rod at the center, and this at the top we have the positive terminal. And around that we have a number of layers. Let's discuss that what exactly we have that layers. At the top we have the protective covering, that red color, especially if we are talking about the dry cell, the red or the blue, the company's logo is written, that is a protective cover. After that we have the inner layer, that is of a zinc cover. You can see if you have opened the dry cell, you might have observed that inside we have a grayish color layer. So that is the zinc cover. After that we have a electrolyte, that black color material which is present inside. Then the divisor we have in between, and then the manganese dioxide in a inner coating we have the dark color. And this makes all is nothing but as a dry cell. And at the bottom of it, if you will observe, the bottom of that is a negative terminal we have. So positive at the top side and the negative on the bottom side. Now we will see some theoretical part they have mentioned over here. You can see in this part the zinc metal layer. This is a negative terminal of the cell. That zinc layer what we are having, that is a negative, that outer part of it. There is another layer inside. An electrolyte is filled between these two layers. The electrolyte contains negative charge and positive charge ions, and that ions are actually carrying the energy between positive material and the negative material. The electrolyte is wet pulp of zinc chloride and ammonium chloride. These two are used, and they are producing the positive and negative charged ions. There is a graphite rod at the center of the cell. This is positive terminal of the cell. A pest of a manganese dioxide, that is MnO2, is filled outside the rod. This layer is a manganese. This purple color you can see now, that. And a pest of that is filled outside the rod because of the chemical reaction between this. That chemical reaction is not a part of this chapter. Only for understanding they have given. Is produced on two terminals, graphite rod and zinc layer, and an electric current flows in the circuit, and then the electrical current flows through in the circuit. Now the next part they have given is about the lead acid cell. In this we have the acid present. This you can see, this is the acid part, and the two rods are used in it, made up of a lead and lead oxide, and they are connected with the two terminals, and that gives a voltage between that, because the electrical charges are flowing inside this acid. Acid makes a conductive material, or used as a conductive material between the two electrodes, and then the charges flows between them to produce a potential difference across these two rods. And this battery you can find out in a car battery or the truck battery or the inverter batteries. This particular kind of batteries are used in that. Now the next part they have given is about the cell holder they have shown over here for the connection, that we will see later part. They have given in a detail over there. Then next part is another type of a cell they have given over here, that is the nickel and the cadmium. These days a variety of gadgets are available which are required to be carried to different places. Such gadgets are nickel cadmium cells. The cells deliver 1.2 volt potential difference, and it is a rechargeable. We can recharge it. We can supply the energy to it and we can recharge it. It's having a longer life as compared to the dry cells. Next they have given is about the electric circuit, that already we have discussed in the previous part. Like plug key is nothing but like a switch, cell is a source of energy, and the electrical bulb and the conducting wires, they all are connected in a series form, one after the another. Next, connecting cells. Whenever we want to connect the electrical cells, we connect them positive to negative. We always connect them in a series, one after the another, and the total potential difference will be the sum of each individual cells. That we will see in the next part with the picture. Before that, they have given over here the another research work, that is a lithium ion cells are used in modern equipments, for example smartphone, laptop, etc. And this lithium ion cells, why it is used? Because it's having a longer life as compared to the other cells. Now in the next part, they have shown about the electrical cells, how they are connected, connecting a cells with each other. We had already discussed about that every cell is having a positive and negative terminal, and if we want to connect them, negative of a one cell should be connected to the negative of one cell should be connected to the positive of the another cell. It should be properly connected, and then the series of that we can form. You can see over here the positive of one is connected to the negative of another. If you want to see this, this is connected this way, and then the positive connected to the negative of the other, then this is connected over here, and so on. It goes on continuously. Means the series of dry cells we can connect, and the total potential difference will be the sum of individuals. Suppose if this all are a 1.5, so when we will connect this, it will become 3. When we will connect this one, this will become 4.5. When we will connect one more to it, then the total will become 6 volt. Means it will go on adding 1.5, 1.5, 1.5, 1.5. It will go on adding that way. So this is about electrical part in the chapter. In the next part, we will discuss about magnetic or the magnetism.